Look at alkene reactions. The first type we're going to look at is called addition reactions. Basically, what's going to happen is we're going to break apart that double bond into two single bonds and then add stuff across that double bond. The first one we're looking at is hydrogenation. Now, that means I have hydrogen. So I'm going to add hydrogen across that double bond once I break it. And I need some type of catalyst for this. A lot of times, we can use something like palladium, platinum, nickel. I mean, whatever you have on hand is going to work fine. So let's jump into a quick example here. Okay. So this one right here is actually 2-butene. So let's label it. Okay. And so what's going to happen is I'm going to break this double bond. So we'll say I have hydrogen gas and platinum there. I break apart this double bond. So it's between carbons 2 and 3, and I'm going to form two single bonds. So I've broken apart these bonds here. Now what happens is hydrogen can add on carbon number 2 and on carbon number 3. Basically what I've done is I've made this into an alkane. So I went from an alkene into an alkane. This is just butane. So I've gone from an alkene to an alkane. I've broken apart that double bond. I've added two hydrogens across it. Let's do another example with this. Say I have cyclohexene there. I'm going to hydrogenation. I have hydrogen gas and a catalyst. I'm going to break this apart, form two single bonds. And then I'm just going to add hydrogen across it. You don't have to show the hydrogens on there, but when we first do the reaction, it may be easier to do that. You can draw it like this. Not very good. Okay. These are the same thing. But again, I've gone from an alkene to an alkane. Let's jump into another one here. We're going to look at hydration. So hydration basically means now I'm going to add water. I'm going to draw it like this. Oftentimes when I draw water, I'll draw hydrogen and the OH. I'm going to add hydrogen on one end, OH on the other. Again, we need a catalyst. When I write H plus means this is acid catalyzed reaction. So let's go into a reaction here. Let's look at this one right here. This is ethylene or ethane on there. Again, I'm going to add water and a catalyst. Basically, what's going to happen is I'm going to break up the double bond. Okay. Add hydrogen on one end, OH on the other. So basically, I've gone from an alkene to an alcohol. This alcohol is actually ethanol. One thing I do want to mention, this right here is called a symmetric alkene. What I mean by that, if I look at carbon number 1 and carbon number 2, they both have two hydrogens on there. Now we're going to have another one in a second in which one carbon is going to have a different number of hydrogens than the other, and that's going to affect where the hydrogen and the oxygen go. But if they're both symmetric, we just add HOH anywhere, and then we're going to be set. But let's look at an example which is not symmetric. let's look at this one right here. Now, a couple of things. Again, this is going to be a hydration. A couple of things. If I look at where the double bond is at, so carbon number 1, carbon number 2, notice that they have a different number of hydrogens on there. Carbon number 2 has 1 hydrogen, and carbon number 1 has 2 hydrogens. Now, the rule is that I'm going to add the hydrogens to the carbon with the most number of hydrogens. We don't have to go through all the reasons for that, but for now, just say, okay, whichever one of these carbons has more hydrogens, I'm going to add that hydrogen to that, and then the OH will go to the other one. So in this case right here now, carbon number 1 has 2 hydrogens, so this is where the hydrogens are going to go to, which means now the OH goes to carbon number 2. So I'm going to break this. Let's go down here. Okay. Going to add a hydrogen here, the OH there. So again, this place, it did make a difference when you have that. This is actually called isopropyl alcohol. We don't have to worry about the name right now. But again, I've gone from an alkene to an alkane, but I got to add a hydrogen to the one with the most number of hydrogens. Let's do one more example with this. Let's do a cyclic one. Got the double bond right there. So in this case right here, we have to count up the number of hydrogens on each one of those carbons along a double bond. So again, it's a hydration. This is where, even though we don't draw hydrogens for these stick figures here, I will count them up. So this is going to be carbon number 1, carbon number 2. On carbon number 1, let's count up how many bonds it has. So this is carbon number 1 right here. It has 1 bond here, 1 bond there, and then 2 bonds there. So carbon number 1 has no hydrogens. So there's no hydrogens here. So you just got to count up. Remember, carbon's got to have 4 bonds. So the carbon number 2, I got, like, carbon number 2. I got 2 bonds here, 1 bond there. So it means now I have a hydrogen there someplace. So I would draw a hydrogen there. So I got a hydrogen with that. So carbon number 2 has 1 hydrogen. Carbon number 1 has 0 hydrogens. So the hydrogens, I got to go on carbon number 1. The OH has to go on the other one. So when I do this, so when I do that, when I break that up, notice that I add an extra hydrogen here and then an OH there. So again, I've gone from an alkene to an alcohol, but again, it makes a difference now where I add the hydrogens, especially for these asymmetric. If symmetric doesn't make any difference, but for these symmetric, it does make a difference. So we'll finish this up by looking at polymers.